All right, so here we have a situation where the denominators are different and we have multiple terms in our numerators. Okay, so this is called a complex equation. All right, it's complex because we have denominators that are different, and we have multiple terms in our numerators. All right, so let's solve for x here. Now, we already saw that the common denominator between 15, 10, and 5 is 30, all right? And it happens to be the lowest common denominator. If you're going to have to work with common denominators, you may as well work with the lowest common denominator, because why work with higher numbers than you have to, okay? So in this case, lowest common denominators is actually a good thing. All right, so we already said that we can go with 30s in our denominator. All right, let's start over here. To pump up 15 to 30, I need to multiply by 2. So if I multiply the denominator by 2, I need to also pump up its numerator by a factor of 2. So that's it gives us an equivalent fraction. Okay, so let's start over here. We put parentheses around our numerators if there's more than one term in the numerator, and you'll see why in this case. 5 pumps up to 30 by a factor of 6. We need to pump up the numerator by a factor of 6 if we're going to have a resulting equivalent fraction, okay? So why don't we multiply the top by 6? Do you see why it's so important that I put the numerator in parentheses? Because now I'm multiplying 6 times all of this. If I didn't have parentheses here, it would be very tempting to say, okay, I'm just going to multiply 6 times the 4x and then subtract 1. Oh, no, no, no. You can't do that. You need to distribute this 6 over all of the terms in the numerator. That's why this parentheses, when we put it in, is a really great way to remember that. Okay, so anyway, we have 6 times 4x minus 1. And then here, we pump 10 up by a factor of 3 to get to 30. So we need to pump up the numerator by a factor of 3. So we'll multiply 3 times the quantity 3 minus x. All right, great. So now, what we can do is we can actually work with these fractions because they have common denominators, all right? So what we can do is we can say 6 times the quantity 4x minus 1 minus, because there's a subtraction symbol here, we're subtracting 3 times 3 minus x, okay? And this is all going to be over this common denominator of 30 now. And then we keep 4 30ths on this side, all right? So, to make some more room here. All right, let's start distributing, which we can do successfully because we left our parentheses in, so we know what we're distributing over. 6 times 4x is 24x. 6 times negative 1 is negative 6. All right, now, we have a negative 3. We're multiplying it times the 3 in the inside the parentheses as well as the negative x, all right? So negative 3 times 3 is negative 9, all right? Negative 3 times negative x is a positive 3x. Negative times negative is a positive. Now, if you're having trouble seeing that you should really distribute this negative, and that's such a crucial thing in these problems, what you can do is, do you see that negative 3 is the same thing as saying adding a negative 3? Both of these things are the same, okay? So if I were to subtract 3 or add a negative 3, it's the same thing. So if it helps you out, instead of having this negative here, you can say it's really like adding a negative. So subtracting is like adding a negative. Now do you see it's more obvious maybe that it's really negative 3 times what this quantity is right here? So then if you feel more comfortable doing that, you'll come up with the same exact result. So that's totally fine. Again, it's all over 30, and here we just bring over the 4 over 30. Okay. Now, since the numerator over here is clearly more than one term, we're going to want to wrap it in a parentheses. Okay? To get rid of this 30 in the denominator, let's multiply it by 30 over 1. All right? Because now these 30s cross out to just cancel 1s. Whatever we do to one side, we have to do to the other because, again, it is balancing an equation, making sure it's always balanced. So we're going to multiply this side by 30 over 1 as well. Lo and behold, those cancel out to 1s. So long story short, we're left with 24x minus 6 minus 9 plus 3x equals 4. Okay? Do you see how we made this complex equation now a simple equation? Because we don't have any denominators right now. So this is a much easier problem for us to solve. So maybe in grades past you were given this in the first place, but we had to do all of that work now that we had a complex equation to get it to this point. And now we can use the skills that we know about inverse operations and our properties of equality, of making both sides equal, is something that you have with past skills. But getting to this point was sort of the complex part of this problem. So now all we need to do is what we've known before, combine like terms. We have 24x here, we have 3x here, we combine them, that's 27x. Then these are like terms, negative 6 and negative 9. Negative 6 and negative 9 combine to be negative 15, and then that equals 4. Now we're going to have to isolate x here. So why don't we get rid of this negative 15? So we do its additive inverse, all right? But whatever you do to one side, you have to do to the other side, all right? So then that leaves us, that crosses out to just to 0, all right? So we're left with 27x on the left-hand side and 4 plus 15 on the right-hand side. 4 plus 15 is 19, okay? And now this 27 is being multiplied against this x. The only way that you can undo multiplication is with its inverse operation. The inverse operation of multiplication is division, not any other operation. So you can only divide this by 27. You cannot try to subtract 27 from here, for instance. No, you have to break a multiplication bond with division. All right, so 27 over 27 just cancels that to 1. So 1 times x, you've got x on the left-hand side and 19 over 27 on the left-hand side. 19 over 27, there are no common factors of 19 and 27. So this is just a fraction that's already reduced. And that's our answer. X equals 19/27.